Welcome to CSEGURU. In this session, we will discuss the topic circular queue operations. Already in the previous session, we have discussed about the introduction to circular queue. What is the drawback of linear queue and why we are going for circular queue? That concept, everything we have discussed. Now, the basic operations of circular queue are insert operation, which is nothing but enqueue operation. In queue data structure, insertion, we will call it as enqueue. And delete operation is nothing but dequeue, and peek operation is nothing but the front operation. Okay. So here insert operation will add an element at the end of the queue. Delete or dequeue operation in the sense, it will delete an element at the front of the queue. What is the front pointer position? In that position, what is the element? Just it will delete the element and it will increment the front pointer by 1. That is delete or dequeue operation. Front or peek operation in the sense, in the front pointer position, what is the element? Just it will check and return the value. That is nothing but front or peek operation. So these three are the basic operations of circular queue. First, insert operation. There are three conditions we need to consider for circular queue insertion. If front is equal to 0 and rear is equal to max minus 1. That is, front is pointing to 0th memory location only, but rear is pointing to max minus 1 location. In that case, circular queue is full. So here, if you are considering the circular queue, front is pointing to 0th memory location only, but rear is pointing to max minus 1. Okay. In that case, what is the meaning? Whatever the memory location you have allocated, all the memory locations you have placed the value. That is the meaning. So here 10, 20, 30, 40, 50 and 60 is there in the sense. This is front pointer and this one is rear pointer. So here in this case, what is the meaning in the sense? Whatever the memory location you have allocated, all the memory locations you have placed the values. Okay, so in this case, circular queue is full. You cannot able to perform new insertion. Okay, next. If rear not equal to max minus 1, then rear will get incremented by 1 and then you can perform the insertion. Suppose here if you are considering rear position is not equal to max minus 1. Okay. In that case, what is the meaning? Still there are free memory locations. So you can place the element here. Okay. So here suppose rear is pointing and here front is pointing in the sense. If you want to perform insertion in this circular queue, just increment the rear position by 1 and place the element. Now rear will point to this memory location. If rear is not equal to max minus 1, meaning is whatever the memory location you have allocated, all the memory locations you have not placed the value. Still memory location is free. You have not reached the maximum size of the circular queue array. That is the meaning. Third condition is front is not equal to 0, but rear is equal to max minus 1. What is the meaning? So here, if you are considering this as the circular queue, this is 0, 1, 2, 3, 4 and 5. Okay. Here, front is not equal to 0, but rear is equal to max minus 1. Okay. So here, now front is pointing here and rear is pointing to the last memory location. It is max minus 1. Okay. What is this condition? Already you have inserted elements from 0th memory location. But these two memory location, you have deleted the element. Now this memory location is free. In linear queue, this starting memory location you cannot able to utilize. To overcome this only, we are going for circular queue, right? So in this case, what we have to do? Set rear to 0. Rear pointer you set to 0 and then place the new element. If you want to insert, then place the new element. So these three are the conditions for circular queue insertion. If front equal to 0, rear equal to max minus 1, circular queue is full, you cannot able to perform insertion operation. If rear is not equal to max minus 1, free memory location are there. So just increment rear position by 1 and place the element. Suppose if front is not equal to 0, but rear is reached max minus 1 position in the sense, reset or reassume the rear pointer to 0th memory location, then place the element. You can utilize the starting memory location element where already element is inserted and deleted now. Now memory is free. That we can able to utilize in circular queue. That is the advantage in circular queue also. Okay. So these three are the conditions for circular queue insertion. So here we will check the algorithm for insert operation. If front equal to 0, rear equal to max minus 1. What is the condition? For example, consider this circular queue. Front equal to 0. Okay, this is front position. And rear equal to max minus 1 position. What is this condition? All the memory locations, some elements are there. That is the meaning. Now, whatever the size of the array you have allocated, to all the memory locations, elements is placed. Now, what happens? Circular queue is full. So, write overflow message, go to step 4 and then exit. So, this is the first condition for insertion. You have to check whether circular queue is full or not. If it is full, you cannot able to perform insert operation. Next, step 2. If front is equal to -1, rear equal to -1. What is the meaning? Queue is empty. Okay, queue is empty. In this case, if you want to insert a new element in the sense, set front and rear pointer to 0th position. Now you have to set both front and rear pointer to 0th position and then place the element. Go to step 3, place the element. Okay, this is the next condition. Next is else if rear equal to max minus 1. Now rear is pointing to max minus 1 position and the front is not equal to 0. Meaning is here already some element you have placed. You have deleted. Okay, elements you have deleted. Now front is pointing here. Okay, and all the memory locations elements are there. Okay, rear equal to max minus 1 position, that is 7th memory location it has reached, and front is not equal to 0. Front now it is pointing to 2nd memory location. This is 0, 1, 2. Okay, in this case what we have to do? This memory location and this memory location is free now. You have deleted the element, now it is free, right? You have to set rear to 0th position. Reset rear to 0th position, and if you want to insert a new element, place the element. Position you have deleted the element already. Now it is free only. So set rear pointer to 0th position and place the element. Go to step 3 and place the element. What is the element you want to insert? You place that element. Next condition, else part if you are considering, rear is equal to rear plus 1. This is what is the condition. Here 0th memory location 1, 2, 3 up to 7. Okay. Now this is 10, 20, any element you can place, no restrictions at all. Okay, this is front pointer and this is rear pointer. Now rear is not equal to max minus 1. Okay, and front is also first position only. In this case, simply what we have to do, just increment the rear pointer by 1 and then place the value. What is the value you want to place it? Just to place the value. That's it. Okay, so here 4 conditions. That is, first you have to check whether the circular queue is overflow or not. If front is 0 and rear is max minus 1, circular queue is overflow. Okay, you cannot able to perform new insertion. Suppose front and rear is pointing to -1, circular queue is empty. What is the element you are going to insert? That is the first element. So set front and rear pointer to 0th position and place the element. Suppose if this condition is false, else if rear is equal to max minus 1 and front is not equal to 0. That is, already in front position, some 2 elements you have implemented deletion or dequeue operation. So that memory location is free, but rear has reached the maximum size. In that case, reinitialize rear pointer to 0th position and then place the element. Suppose if both the condition is false, in the sense, what is the meaning? Circular queue is not empty, and here rear has not reached the maximum position. So what you can do? Just increment rear position by 1 and place the element. These are all the conditions for circular queue insertion. Next, circular queue delete operation. Here also you need to check the condition. If front is equal to -1. So when front and rear is -1, circular queue is empty. Empty queue, you cannot able to perform delete operation. Full queue, you cannot able to perform insert operation. Empty queue, you cannot able to perform delete operation. So it will print underflow message. This is first condition. Second condition is if front is equal to rear. So after deleting the element at the front of the queue becomes empty. In that case, set front and rear to -1 position. For example, consider the circular queue like this. If front is equal to rear, here element 10 is there, 20 is there, 30 is there. Okay. Now rear is pointing to this position and front is also pointing to this position. When it will happen? Already you have inserted element 10, 20 and 30, but how front will point to 30? If this is deleted and this is also deleted, in that case front will point to 30. In that case, what it means? After deleting this element 30, you have to set front and rear to -1. Why we have to set? Meaning is circular queue is empty. So you can able to start from new memory location. The starting memory location itself you can able to perform insertion. That is the meaning. If rear and front is pointing to same memory location, delete that element. After deleting, set front and rear to -1. Okay, this is the second condition. Next, if front is equal to max -1. Suppose if this is the circular queue and front is pointing to max -1 position. Now front is pointing here. This is 0, 1, 2, 3, 4, 5. Front is pointing to max -1 position. Some element is there here. Okay. After deleting the element at the front, set front is equal to 0. In this case, if you want to delete that element in the sense, after deleting, set front to 0. Now rear also will be pointing here only. That is the meaning. Set front to 0. If front is pointing to max -1 position, suppose here rear is pointing in the sense, here rear is there in the sense, after deleting this element, reassume front to 0th memory location. Set front to 0. That is the meaning. So these three are the conditions we need to implement for delete or dequeue operation in circular queue. Now we will check the algorithm. If front is equal to -1, what is the meaning? Circular queue is empty. That is the meaning. So what you have to do? Just print the underflow message. If the circular queue is empty in the sense, you cannot able to perform delete operation, go to step 4. Suppose if this condition is false in the sense, step 2, value equal to queue of front. So what is the value you want to delete it? That will be pointed to the front pointer, right? That will be the front pointer. For example, here 0, 1, 2, 3, 4, 5, 6, 7. Okay. And here now front is also pointing and rear is also pointing here. Meaning is here elements are deleted. Just we will consider. Suppose if the element you want to delete it in the sense, what is the element you want to delete it? You consider this element. Okay. And step 3, if front is equal to rear, front and rear is pointing to same memory location, delete this element, reset front and rear pointer to -1. So front and rear pointer you have to reset to -1. What is the meaning? The circular queue is empty. You need to reassume from the starting memory location for new insertion. That is the meaning. That's why we are setting front and rear pointer to -1. Okay. So this is this condition. Suppose you want to implement this else part in the sense, you consider this queue. If front is equal to max -1. Now front is pointing to max -1 position. Okay. And suppose rear is pointing here. In this case, what we have to do? Front is pointing to max -1 position. After deleting this element, set front to 0. Set front pointer to 0th position. Automatically this position will be deleted. So when it reached max -1 position, the next increment will be, if you are incrementing front pointer, next location will be 0, starting location only. Okay. Else, just increment the front pointer by 1. Meaning is, for example, else part you will consider, this is your circular queue. Now front pointer is pointing to 30 memory location. What is the meaning? Now this 10 and 20 already it is deleted. Rear is pointing to 50. Okay. Suppose if front is not equal to rear, this condition is false. If front is not equal to max -1, this condition is also false in the sense, just increment front pointer by 1. Now front pointer is pointing to second memory location. Increment front pointer by 1. Now front pointer will point to third memory location. So automatically this element will be deleted. Okay, if both the condition is false in the sense. Okay, so these three are the basic condition. First is You are checking for empty circular queue. If condition is true in the sense, just return underflow message and exit. Otherwise, the friend pointer, what is the value? Just you consider it. This is for printing the element what you have deleted. Just consider the friend pointer value in step 2. Third step, check if front is equal to rear. Meaning is if both is pointing to same memory location, that is the last element you are going to delete in the circular queue. So after deleting, set front and rear pointer to -1. Meaning is you can reassume from the starting memory location. That is the meaning. Else, if front is max -1, if front is pointing to max -1 memory location in the sense, if you are incrementing front pointer, it has to go to 0th memory location. So that's why you are setting front to 0. Automatically this memory location, if there is an element, it will be deleted. Else, if both the condition is false in the sense, meaning is here if front is pointing to different memory location, rear is pointing to different memory location. So just increment front pointer, automatically element will be deleted. So these three are the conditions for circular queue delete or dequeue operation. Next is circular queue peek or front operation. Just it will check and display the front element in the circular queue. Okay. So to implement the peek operation, you need to check the condition whether front and rear is -1. If the condition is true in the sense queue is empty, you cannot able to implement peek operation. Otherwise, display the front element. That's it. Okay. So here the algorithm, if you are checking in the sense, if front is -1 and rear is -1, just it will return the underflow message and then it will exit. Otherwise, just it will print the front element in the queue. Circular queue. For example, if this is the circular queue, if you are considering in the sense, what is the front element if it is pointing in the sense? Suppose front is pointing here in the sense, just it will display the front element. What is the element? It will display. Rear is pointing here in the sense, just it will display the front element. So that is the purpose of front operation. Okay. So here it will display 30. The front pointer to which memory location it is pointing, in that memory location, what is the value? It will display. So these three are the basic operations in circular queue as like in linear queue only. Enqueue, dequeue and front operation. Thank you for watching this video.